everyone. In this video, we are going to discuss GATE 2012 question in the network subject. The first question, protocol data unit for the application layer in the internet stack. The answer is option C, message. In the internet stack, we have 5 layers. The first layer, physical layer. The PDU of the physical layer is bit. The next is data link layer, and the PDU in the data link layer is frame. Third one, network layer, that is known as the PDU in this layer is known as either packet or datagram. If we follow the connection oriented protocol, we are using the term packet. If it is connectionless, we will use datagram. And in transport layer, the PDU is known as segment. In application layer, it is known as message. So, the answer here is message. The second question, which of the following transport layer protocols is used to support electronic mail? To support electronic mail, what is the transport layer protocol? Which is answer option C, TCP. For electronic mail services, we need different protocols like SMTP, POP, and that are in application layer. In application layer, we need two protocols, that is SMTP and POP. SMTP means Simple Mail Transfer Protocol, which is used to send the message from the computer to the mail server. And POP is Post Office Protocol, which is used to download the message from the mail server to the computer. So, in the sender side, SMTP will work, and in the receiver side, POP will work. And in transport layer, TCP is used so that all the mails are delivered, delivery is guaranteed. The next question, in the IPv4 addressing format, the number of networks allowed under class C. The addresses are classified into classful and classless. In classful, it is classified as class A, B, and B, C, and D. So, IPv4 address has total number of 32 bits. Out of this 32, 8 will be used for network ID, and for the host, the remaining 24 bits will be used in class A. And out of this 8, 1 will be used to identify the class A. So, remaining 7 bits are there, so that 2 raised to 7 number of networks are possible. In class B, 16 bits are used for network ID and 16 for host. Out of this 16, 2 will be used to identify this class B, and remaining 14 will be used for the network part, so that 2 raised to 14 networks are possible. And in class C, 24 bits for network ID and 8 for host, so that out of this 24, 3 bits will be used for C, and remaining 21 bits are there. With that, 2 raised to 21 number of networks are possible. So the option is, and the answer is option C. The next question, an internet service provider ISP has the following chunk of CIDR based IP addresses available with it: 245.248.128.0/20. CIDR means it's classless interdomain routing. So this is classful addressing. The thing which I have explained in the previous question was classful addressing. In this question, it is classless addressing. So this value after the slash is used to represent the number of networks. Here it is 20, that means 2 raised to 20 number of networks are possible with this ISP, and out of this 2 raised to 20, out of this 20, we are using this IP address. Out of among these 2 raised to 20 networks, this ISP has got this address. So then ISP wants to give half of this chunk of addresses. How many addresses? Actually 20 bits are used for network. That means remaining 12 bits for the host. That means 2 raised to 12 number of host addresses are with this ISP. Out of this 2 raised to 12, half of this provided into organization A. That means 2 raised to 12 by 2. What is that? 2 raised to 12 minus 1, which is 2 raised to 11. So 2 raised to 11. half of the addresses given to organization A. Okay, half of the address is given to organization A, and half of the remaining, that means quarter, is provided to B, and the third subnet is there, which is C. So total number of addresses are classified into 3 subnet, provided to 3 subnetworks. So for class A, we are using 2 raised to 11 number of hosts are there. That means for the mask value will be 32 minus 21. Sorry, 11, 2 raised to 11 host addresses are used for class A, so that 32 minus 11 means it is 21. 21 are used for network ID. So the mask value will be 21 for class A. So option A and option B have the same 21 for class A. And in class C, the remaining one, that means half of the remaining means quarter of the total address. So 2 raised to 12 total addresses are there. Out of that 2 raised to 2 raised to 2 will be divided, so that 2 raised to 10. So 2 raised to 10 number of hosts are there in, that means 1024 systems can be connected to class organization B. So what will be the mask for this class B? 32 minus 10, which is 22. So slash 22 will be the mask for class B. So in option A and B, in terms of mask, it is correct. And out of this, we have to identify the subnetwork address. So for class A, what is the IP? 245.248.128. 128 means 100, 4 more zeros. Then 8 zeros at the end. Okay. Okay. So what is the subnet mask for class A? 21. That means 21 bits will be used as network address. Then remaining 11 bits are for host. Okay. So this 8 plus 3. These many number of bits are used for the host address. Out of this 11, we have to take out of this 11, we have to take 1 bit to identify the subnetwork. So this bit can be either 0 or 1. In this options, actually this is set to, in the this is for organization A. 1 bit will be taken for the subnetwork, and for organization B, 2 bits will be taken for the subnet. I will explain once more. For the organization A, the mask is /21. That means for the 245, 8 bits are there. For 248, 8 bits are there. So 16 are there. And remaining 4 4 more bits are used for the ISP address. That means this address. And for organization A, we have used 21 bits as the network ID. So for 20 bits are for network, and the remaining 1 bit will be for the subnet. So this 0 will be, this bit can be either 0 or 1. Okay, this is about the class A. If it is 0, this address will be 128. If it is 1, this will be 136. Okay. In the for the class B, the mask is 22. That means 20 bits are used for the ISP address, and the remaining 2 bits. That means these 2 bits. It can be either 00 or 0 1 or 1 0 or 1 1. Okay, these are the possible values for these two bits. So when we look at these option A and B, both of this class B addresses are 128. That means this is set to 0 0. So for class B we have chosen this 0 0 bits, so that the value will be 128. Okay, then since this is set to 0 0, for class A we need this bit to be 1. If we set this to 0, the clash will be there, so we need to set this bit to 1. So what is the value? 2 raised to C, this is 2 raised to 0, 2 raised to 1, this is 2 raised to 2, and this is 2 raised to 3. So 2 raised to 3 means 8. 8 plus 128, that is 136. So this address will be chosen for the class A, and this is, when we set this two bits as 0, it is 128 itself. So option A will be the right answer. Thank you. We will see you in the next video with some other questions from the GATE.